Okay, let's continue on looking at entomology and the law. We're going to look at some of the federal rules when it comes to evidence now. So we talked about the Fry standard and the Daubert standard. As times go by, as these rules get tested and retested in court, they become refined. So the Daubert standard, therefore, has been changed a little bit, has been added to, all of that sort of stuff. The result was the federal government deciding that they needed to have a certain level of rule in order to allow scientific evidence into a scene. This ended up with the Federal Rules of Evidence, specifically Federal Rule of Evidence 702. This particular rule deals with scientific evidence as it comes into the courtroom. So the Federal Rule of Evidence 702 states if scientific, technical, or other specialized knowledge will assist the trier of fact to understand the evidence or to determine a fact and issue, a witness qualified as an expert by knowledge, skill, experience, training, or education may testify thereto in the form of an opinion or otherwise. Sounds super law, right? But what this speaks to is specifically the type of person that can give scientific evidence in court. So this federal rule is followed by all federal courts and really all states. It's usually easy for states to adapt the federal rules to make it a little bit easier. So what this is stating, all right, you're bringing in some scientific evidence, yes? The person that's going to be talking about this scientific evidence had better be a qualified person, a witness that is qualified through his or her expert knowledge, through his or her skill, through experience, through training, through their education. Every time I go and testify in court, I have to go through a test, basically, that allows the court to determine if I meet these standards. Once I've gone through that test once in a particular jurisdiction, though, it's on record that I am approved as an expert witness, so I don't have to do it again. But usually what it involves is I go and I sit on the stand, and one of the lawyers, whoever called me, talks to me about, okay, what is your position? What is your name? Dr. Adrian Brundage, what is your position? I'm a professor here and here, and I'm a board-certified forensic entomologist. What does board-certified mean? I go through everything I told you last lecture. This is what it means. This is what I've done. How many cases have you worked? What is your experience? What is your educational background? Etc. So they ask all these things. What is my knowledge? What is my skill, my experience, my training, my education? So that's showing the court that, yes, I am a qualified expert witness. And then at that point, the judge can say yes or no if I'm allowed to speak to the evidence. I haven't been denied yet, so that's good. This is why that whole qualification, the certification helps a lot, because it's really easy to say, look, I'm certified by a national body. Here you go. And so then they can see those standards. If you don't have that certification, you can still testify as an expert witness. You can still speak to scientific, technical, or specialized knowledge. All you have to do is meet these qualifications. So the lawyer will come to you, or the lawyer will sit in court and ask about your skill level. Why are you qualified as an expert? We see expert witnesses going in without, say, a PhD, without really any educational experience, but maybe they are the top of their field. Maybe they are the person who wrote the textbook. Maybe they are somebody who's well known in the field, who's done a lot of work in it, but it's not being taught anywhere. They just have to show that they know what they're talking about. Okay. Now, this, as you might imagine, is a pretty broad thing, though. So there's some basic questions that need to be answered by the potential expert witness in order to, what's the word I'm looking for? In order to support the fact that they are, in fact, good expert witnesses. Those 3 questions that tend to be answered during this portion of the trial are things like, is it good science? What they are talking about, is it actual science? Is it good science? 2, does it incorporate reliable data? And 3, is the data applied by a qualified expert? So this has to do with these federal rules of evidence. If all of these questions can be answered, and then the person who is being asked to testify can be considered a qualified expert, then this evidence is admitted in court. Now let's go over these questions a little bit in depth. Number 1, is it good science? This is an open-ended question, isn't it? So science is one of those amorphous words where people, when you say science, everybody sort of knows what it is, but try to define it, and it's rough. Now, the idea of scientific versus technical evidence. When we talk about scientific evidence, we're talking about knowledge that is generated through the scientific method. So these continued uses of the rules of evidence, they've led to a lot of need for definitions. They have the necessity to distinguish between what is considered quote unquote scientific evidence and what is considered quote unquote technical evidence. Okay, so in a particular case, let's say there was a case where the court tried to use the Daubert standard to determine the admissibility of forensic document evaluation. They found that while the idea of analyzing documents was considered a highly regarded technique among the forensic community, as well as the specific forensic document analysis people, it is not a well-researched area of expertise. There's not a lot of lab research. There aren't papers published. There isn't peer review, that sort of thing. And therefore, it's not accepted by people outside that forensic document evaluator realm. However, the evidence was allowed into the court as technical evidence rather than scientific evidence. So subsequent cases had to end up actually defining the term scientific versus technical. This is literally a technicality, how they got this document analysis into the courtroom. So again, this word scientific, this is as it is defined by the courts, and there are court cases where this is cited. So scientific evidence is knowledge that is generated through the scientific method, knowledge that is gained by subjecting a testable hypothesis to experimentation in an effort to disprove this hypothesis. Okay. We'll go into this quite a bit, but this is the crux of science, isn't it? You come up with a hypothesis and then you try your damnedest to disprove it. If nothing works, all of your evidence is now supporting that hypothesis. That's the scientific method. So the court explicitly states that information that defies testing, no matter how defensible or how deeply held the opinion, is not considered scientific. If you cannot test it, it is not science. That is the major difference between opinions and technical data and whatnot and scientific data. It must be testable. Now, we test it using the scientific method, and I'm sure you have seen the scientific method over and over again throughout all of your studies in high school and all that. This is the reason we want you to know what this method is, because you continue to use it throughout your lifetime. And honestly, as I am going through and doing research now, I still have to go back and remind myself of this actual method so I don't miss a step, so I don't mess something up. It's just good to remind yourself. So let's go through it step by step. The scientific method always starts with an observation. So that observation is where everything starts. And I'm sure you have heard the scientific method before where it starts with a question. You question something, but you can't formulate a question until you notice something. So this observation is a description of a phenomenon or a group of phenomena that you notice. You notice, oh, the sun rises in the east. Interesting. You notice that insects land on bodies. Huh. Okay, so you've observed this. Now you can create a question. So that second question is this: why do insects land on bodies? Or do insects land on bodies in a particular order? Do they last a particular amount of time? What insects show up first? There's a whole bunch of questions that you can come with that observation, right? So that's your second step. 1, you observe insects show up on the body. 2, you create a question. Now, 3 is when you formulate a hypothesis to explain this phenomena or to explain this question. Now, a quick aside, I've noticed there are some major differences between scientists and, say, engineers. My husband has an engineering mathematics background. I'm a scientific background. And I found that when we have a question about something, I will go and I will look up the answer. I will go and see if there is an answer already out there. He will try to figure things out on his own. So engineers in general, I notice, just want to try to figure it out on their own. Scientists in general, I've noticed, we've been trained with the scientific method. So once you come up with a question, you have to go see if there's already an answer out there. This makes it much easier. So this is where the literature comes in, and this is how you formulate your hypothesis. So you come up with your question like, insects land on bodies, what insects show up first? My first step is to go look up if somebody else has already figured this out. You go into the library, you go into the literature. I'll talk about how to do this a little bit later, but you go into Google Scholar and you just search insects on bodies. If somebody else has already done it, fantastic. Your question is now answered. And you have a million more questions that you can come up with. So then you can go on to the next question. But if your question is not answered, you've done a lot of reading now in the literature that will help you come up with an answer or a potential answer to that question. That potential answer is the hypothesis. Now, in physics, the hypothesis often takes the form of a causal mechanism or a mathematical relation. In science, it is based on all this body of information we have in the literature, all these papers and all these other scientists that have come before us and answered a whole bunch of questions that are sort of related to your question. So we can say, let's say the answer to, or the question we have is, do insects show up on a body very quickly? Let's say it hasn't been answered. We can look at a whole bunch of different other literature and come up with, it looks like they show up right away. So we phrase our hypothesis then in a way that allows us to predict the existence of other phenomena or predict quantitatively the results of new observations. So a good hypothesis is testable. A good hypothesis helps you predict what could possibly happen. So we've got our question, do insects show up very quickly after death? Our hypothesis could be, yes, they're going to show up within 10 minutes. Okay, so a good testable thing. A bad hypothesis is something where it's, sure, they'll show up. Why not? Or no, they don't. I mean, that's awful, right? That's not quantifiable, really. So you want to be able to predict what's going on. Then that hypothesis allows you to experiment. So you perform experimental tests of these predictions by several independent experimenters, if possible. So a bunch of people should be doing these tests, not just you. And you need to have these well-rounded, properly performed experiments. If you are unable to disprove your hypothesis, if you are unable to completely negate that hypothesis, then you're going to have these experiments that bear out this hypothesis. Eventually, this hypothesis may be regarded as a theory or a law of nature. More on the concepts of hypotheses and model and theory and law later. Okay, but if your experiment gives data that supports your hypothesis, cool. If the experiments do not bear out the hypothesis, you either reject that hypothesis or you modify it. So this is the key to this description of the scientific method. It's given a predictive power. Okay? You get more information the more you experiment, and the hypothesis allows you to predict what is going to happen. This is one of the things that I adore about science. It's almost magical, isn't it? Except it's science. You get to predict the future. You know, based on past experiments, what is going to happen under certain conditions. awesome. So all of your research, all of your testing, this is going to give you information or support for your hypothesis. You'll get more information. You'll be able to refine your hypothesis. Other people will be able to refine it. It gets better and better and better. Now, it is often said in science that theories can never be proven. They can only be disproved. That is true. You cannot prove a scientific theory. You cannot prove a hypothesis. You can only negate it. That's because we don't know everything. We don't have perfect data. So we can't, without a doubt, say, yep, this is true. Neat. So we'll go into that a little bit more. There's always the possibility that there's a new observation out there, that there's a new experimental technique that was going to conflict with your hypothesis or with your long-standing theory. So you experiment, and you experiment over and over and over again. You analyze that experiment. You make conclusions based on that experiment. Then you can go back and refine your hypothesis. You can test again, and you just keep going. And then this is going to create new questions, new ideas, and this is how science grows. So this is what defines good science. Anything that is admitted into evidence must encompass this idea of good science. If it doesn't meet these criteria, it's going to be excluded, or hopefully it will be excluded by a good judge, a good jury. Next, does the science incorporate reliable data? This is the most controversial area when it comes to Rule 702. The expert witness's job is to present scientifically sound analysis while pointing out weak points in the opponent's analysis, hopefully to educate the counsel so they can be thoroughly attacked. Data that is shown must be shown to be accurate. So a witness is going to write a report that's going to help prove the accuracy of the data. So any of the entomological reports I write have to show the basis in science that proves this data to be reliable, that shows this hypothesis or this theory is supported. The report has to be made available to both the prosecutors and the defense lawyers. It needs to be analyzed for weaknesses and any mistakes or problems not directly pointed out by the expert witness is going to be looked at or brought up by counsel. So you want to make sure when you're presenting data, when you are presenting data, when you are writing your report, you acknowledge that there are weaknesses or what those weaknesses are. And this, honestly, is a really hard part of being an expert witness for a lot of scientists. You don't want to have to say, I don't know. You don't want to have to say, the science doesn't know. I personally hide behind the literature a lot. I use a lot of literature in my case reports. I say, this is what we know. These are the experiments that bear it out. And here is what we don't know. I'll give you later on in the semester an example of one of my case reports, and you'll see there is a whole section of caveats. There's a whole sections of here are some weaknesses and here are some things we don't know. Because if I don't put that out there, then the opposing counsel is going to come at me and say, why didn't you tell us about these weaknesses? So that is something you must acknowledge, and you have to understand the limits of your science and be willing to testify to those. Finally, is data applied by a qualified expert? So each field is different when it comes to qualifications. Some fields only require bachelor's degrees or on-the-job training. Others require terminal degrees in the area. In my area, it's a PhD. Others need an MD. Others need something else. And you need certification. So remember, this was one of the major problems identified by that 2009 congressional report. There is still no standardization required across fields. So depending on what field you go into, you're going to need to figure out what that qualification is and speak to that in court. This can become an issue if you have more than one expert testifying to the same thing. So In entomology, these new standards where you have to have a PhD and board certified stuff, this is relatively new. So you will have forensic entomologists out there that don't have this qualification. It's interesting to see an expert witness who is well known in the field who doesn't have the same qualifications as, say, a board certified forensic entomologist. The council's job is to make it known why both of these witnesses should be considered experts. So this is one of the places where we're having a bit of controversy in forensic entomology. All right. With that, let me know if you have any questions, and I'll talk to you soon.